Okay, so careers in technology. So first, I'm going to start off talking about software developer, and I'm not going to go like super into depth with everything just because I don't want to have you here for like hours on end. So the main points that I'm going to talk about for every different career is approximately how much they make, their median salary, expected job growth, which is really important for y'all, especially that are in high school right now, because most of the percentages that I found were growths from 2018 until 2028. So by the time it's 2028, that's what, 8 years from now, you will be, if you're a freshman, you'll barely be graduating, or you will have graduated 2027 from college, or you will already be a college graduate and you will already be in the field. So really pay attention to the percentage, and you'll probably realize as we go through all the different careers that people in technology make a lot of money. And the reason for that is because supply and demand. So, everyone is all about technology right now. So everyone is looking to create the newest app, the newest game, the newest software, the best website. People who create businesses, they have to have a website to sell their products. So there's a lot of demand, and that is why a lot of these careers make a lot of money. So for software developers, on average, they make about 105,000 a year. Their expected growth is 21%, which is a lot. And what they do is they're pretty much the masterminds behind computer programs and technologies that you can't imagine living without. So I'm pretty sure y'all don't use Facebook, but Instagram, TikTok, they're the ones who are behind all that. So imagine not having that, or not being able to use it anymore. You probably can't even imagine what life was like before technology, but they are the masterminds behind that. There is also cybersecurity engineering, which is super important because they are the ones who are protecting what those software engineers, software developers created. So they look for people to see if anyone's planning a cyber attack to hack into their system. They make about 99,000 a year, and their expected job growth is 32%. So along with that, the more technology that there is, the more protection every form of technology is going to need. So I'm going to show you all two really short videos about people who are security engineers.
Every day I drive into work, I listen to the news on the radio because what happens in the real world actually impacts who may want to go after our company. I'm Jessica Lee. I'm a cyber threat intelligence analyst at Chevron. When I come into work, I begin looking at my hundreds of emails in my inbox that are about the things that have been happening overnight, the different cyber incidents that have happened throughout the world, the different adversaries that have been active, or even predictions into what adversaries may want to do. Oil is something that drives economies for a lot of different countries. I pay attention to anything having to do with oil or natural gas resources. I take that information and I feed it to other teams so that they can make business decisions about how to better protect the company. In college, I majored in linguistics. I have both a bachelor's and a master's degree in that. And I was just fascinated by the type of information that I learned, the way that people scrutinize language and are able to actually pull meaning from it. When we get a phishing email that's in a different language, it can be difficult to determine what language it is in. I can easily spot that. We track different adversaries. A lot of them post on social media or post on websites, and I'm able to look at what they're writing and understand a little bit more about them because of my background. Cybersecurity at a company like Chevron is about keeping the company and the people who work for the company safe. We have operations throughout the world, and we have to protect our information and operations in every single country where we do business.
Vast quantities of data. So I'm going to show you a little video.
This video is going to be about artificial intelligence, research being done, and how to get into this field for those who are looking into what to study in college. Now, what is artificial intelligence? The definition is the theory and development of computer systems able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. Artificial intelligence is a wide field. You probably have something specific you're imagining right now, but let's go over just briefly some applications before going into more depth. The first is self-driving cars. This is all over the news, and as you probably know, we are trying to make cars that are fully autonomous using sensors, cameras, radar, and various software so that cars do not need a human behind the wheel. Elon Musk even predicts that in a few decades, cars won't even have steering wheels because they will all be fully autonomous. Artificial intelligence is being used in finance to make trading decisions at high speeds. Or in personal finance, as an example, there's an app called Digit out there that uses artificial intelligence to analyze income, current balance, and spending habits, and then makes decisions on when to transfer money to your savings and how much to transfer so it makes saving money as effortless as possible. AI is being used to play games like chess, where the goal is to make a computer that can beat the best humans out there, which I will talk about later. It's being used for language translation, such as Google Translate, or on YouTube to generate subtitles simply based on audio. It's being used for publishing. For example, the company EchoBox is creating software to increase traffic for publishers by analyzing how certain people respond and interact with different articles, and then strategically posting content on various platforms like Facebook or Twitter. It can analyze headlines that best serve your audience, look up hashtags that'd be the best to use, and more. AI is big in hospitals and medicine, and research is being done to help with the interpretation of medical images, like with detecting a tumor, in drug creation, creating proper treatment plans, and so on. It's used for email spam filtering. The government uses facial recognition for defense purposes. AI is being used for facial expression recognition to read for emotion, and so much more. Now, before I get into more specifics, let's go over how to get into this sector of artificial intelligence and how you should tailor your education. Now, in terms of undergrad, you won't really see artificial intelligence as a major. You don't start there. The best major to go into, just in general, is computer science. That's probably the best starting point, and I'll explain why soon. But remember, AI is a broad field. Other majors that are good to begin with as well would be math, statistics, electrical engineering, software engineering, or even computer engineering, which are in no particular order. But for artificial intelligence, you really want to consider getting a master's and even a PhD, because a lot of artificial intelligence is research-based, which needs further education. And actually, that's where it's more important to take classes and do projects related to AI. Your undergrad degree, although lays a good foundation, isn't the most important. And again, AI is very broad. If you want to go into robotics, let's say, then there will be moving parts and lots of hardware, like maybe with autonomous cars. And then electrical or computer engineering might be a good route. But with Google Translate, which is also AI, that's a different story because computer scientists are probably working more on that. Computer scientists or maybe mathematicians do more of the algorithm design and mathematical modeling for these systems. While it's possible for a computer or electrical engineer to get into this, they might be doing more of the hardware design. So as always, it's not so black and white as to who can do what, but you should take note of these differences. But now let's dive a little more into artificial intelligence because it gets really interesting. First, artificial intelligence can be broken up into many branches. There's machine learning, natural language processing, like translating a language. There's vision, like image recognition, speech recognition, like speech to text or text to speech, robotics, and more. Machine learning is the big one, which I'm going to talk about, and I'm sure you've heard of this term before. But realize that machine learning isn't the same as artificial intelligence, but it is related and has shown some of the most promising innovations so far. Now, what is machine learning? Well, it's basically about writing software that can learn from past experiences. And by experience, that really means data. If this is new to you, it's a bigger deal than you may think. When you play a game of Super Smash Brothers, you may have played against the computer. Now, did the computer get better over time? No, it did not. You play a level 9 computer a million times, and it's just as good as it was to begin, because it doesn't use machine learning. The computer was programmed to be as good as it was. Now, if it did use machine learning, the computer might start off really bad, but it would learn and get better as it played and made connections, just like you started off bad but got better. But a computer could get to superhuman levels as it kept playing and playing, at least assuming the learning algorithm was designed well. That's the power of machine learning. But let's go simpler. For example,
Okay, so that gives you a little bit of a differentiation between artificial intelligence and machine learning. I don't know why I did that. But that was the most interesting for me personally. So if you're like a gamer and you're really into games, then you might want to look into doing artificial intelligence or machine learning. Pretty cool. So next we have a web developer. So web developer makes about 69,000 a year. Their expected job growth is about 13%. And there are two different types of web developers. There's back end and front end web developers. So when I think about web developing, I usually think about like having a really nice background on a web page, like different fonts that you can use, um, different icons that they have, like click this and it'll take you to a different page or something like that. But that's only the front end. So the front end is only what you see, so how it's designed pretty much. And then there's the back end, which is responsible for the site's technical aspects. So the creation of it, how well it performs, how many people can be on the same website at once, the speed of the website, so things like that. So there's two different types of web developers, and you can focus on either one or the other depending on where you end up working. Some places might want you to only focus on being a back end developer, a front end, or they might want you to be good in both. Then we have a tech lead or a tech manager. So they make about 99,000 a year. Their expected job growth is about 11%. And usually what they do is they have manager in their title. So first, if they're working in technology, they have to be knowledgeable about technology. So you can't just walk up in there with maybe retail manager experience and be like, oh, I want to be a tech manager. No, that's not how it works. You first have to have a foundation in technology so that you know everything that's going on in the organization that you're working in. But you do manage different people. So you have your team and you designate different projects for different people. You split up a task and you collaborate with different managers from different areas of your company to make sure that they together as your individual team and as a whole company, you are aligned with the company's goals. So that is a lot more than just like techie computer coding. It also has a lot of, you have to have a lot of interpersonal skills to be able to manage a team. So next we have a data scientist. So data scientists make about 113,000. Between 2018 and 2019, there was a 56% job growth. And I found a lot of different articles saying or calling a data scientist the best job in America. I think in 2019 or 2018. And it was ranked #1 most promising job in America. And they figure that out by your salary, how much people enjoy the work, how easily, or not necessarily easily, but how locally they can get a job, or do they have to like travel really far. But for data scientists, you can pretty much find a job anywhere close to you, so you won't really have to travel far in order to find a job. And pretty much what they do is they analyze and interpret complex data. They consult businesses based on the data that they found. So think about just a whole bunch of different numbers scattered around everywhere, and they start to kind of group them together and they interpret what that data means. So what does this 236.46, like what does that mean? Is that good for the business? Is it bad for the business? What should the business do to improve?
My name is Rajiv Manjoke, and I am a quantitative analyst.
My name is Elizabeth Tucker, and I'm a quantitative analyst. Quantitative analysts are involved in a lot of things at Google, working with teams like search, ads, YouTube, geo. We're often working with really, really complicated systems, and we're trying to understand how products are doing, where they're doing well, where they're not doing well, and what can be done to make them better.
I'd say about 40% of the time I'm doing some kind of coding. I'm implementing some algorithm I developed. 30% of the time I'm in meetings, brainstorming with someone. And the rest of the time is kind of split between either exploring and sanity checking data or coming up with algorithms.
I started working here because I was really interested in search and the problems in search, and I continue to find that fascinating to this day. We have a variety of backgrounds, and in fact, we deliberately hire from a variety of backgrounds. My background is theoretical math, actually, not statistics. We deliberately seek different perspectives because Google is an international company, and we look at analysis in over 100 languages. So having a diverse perspective as possible is a wonderful thing.
As a quantitative analyst, the impact that you have is amplified just by the scale of Google, by the number of people that are using Google products.
When I look at Google search results, I do feel proud of the influence I've had. I often, though, find myself critical and thinking how much farther we have to go.
Being a quantitative analyst is like being a lifelong student of statistics.
We try to make sure people are working on problems they're passionate about. That way, everyone's happy and analysts produce great work.
My teammates are very accomplished. They're very helpful. It's not a matter of let me do work so that I can do better than you. It's more let me do work so that I can help you. We're all on the same team.
Being a quantitative analyst at Google is so much fun. If you're a data person, having huge amounts of real data to play with and also having an impact on the world around you is such an appealing combination.
Okay, so that was, I know they called it a quantitative analyst there, but it's pretty much a data scientist. Okay, and then next we have a mobile/web app developer. So they make about 73,000. That's average nationally, but I looked up California specifically because California has the highest demand for mobile and web app developers. And they make, so in California, they make approximately 112,000, and the average job growth is 30.7%. And what app developers, mobile and web app developers, what they pretty much do is create apps. So every single app that you have on your phone, your Instagram, Snapchat, your mail, your, I don't know, all of the 30 apps that you probably have on your phone, people created them. And even when you go onto a website, there's different applications within websites that you've probably used before that you didn't even realize it. But that's pretty much what they do. They create the software that goes behind all of that. So you have to be pretty creative if you want to be a mobile web app developer, because everyone wants to create the next newest hit that's going to happen. So you have to be pretty creative when it comes to mobile and web app developing. So here's a video.
So today we are working on a augmented reality application. I've had this idea for a while and I'm really excited to get started. So I'll take you along and show you how I built apps from scratch. And I think it'll be fun. So let's get started. So what I usually like doing whenever I start out a new app is I want to get the idea down on paper, in this case digital paper. But sometimes I write down the idea and sometimes I sketch it out. I think for augmented reality, what I like to do is really just sketch out the idea. And so what I've been wanting to do for a very long time is create an app that, imagine having a tabletop. And what I really wanted to do is to be able to put a 3D map on top of the table. And this map would have the landscape in 3D, would have the buildings, and the roads, and all that stuff. And so using a phone, that's my drawing of a phone, you'd be able to look at this map that is placed on a desk and see the 3D map almost like a Google Maps, but for augmented reality. And I've been wanting to build this for a while, and so today that's what we're going to build. So the next step is to do some research. We need to figure out what tools we need to build our app. So now we know what we're going to build and how we're going to build it. It's time for the best part, writing the code. And we're done. Now it's time to try out the app. And that's how it's done.
Cool. So I don't know if y'all thought that was interesting, but that was pretty interesting to me. Something that I thought about when watching that video, it reminded me of when I've been like furniture shopping, and then it tells you, imagine this dresser in your room, and then it has you like scan your room or like take a picture, and then next thing you know, there's like a dresser in the corner of your room. So that's pretty much exactly what he did. Or if you've ever been shopping for sunglasses or prescription glasses, and you're on an app and it says, imagine yourself with these glasses so you can, so you can better envision yourself, see what you're going to look like with the glasses. And then it has you like take a couple pictures of your face, and then all of a sudden you have glasses on your face. So that's another example of augmented reality. And that's an application that it can be its own app or it can be within another app. So that was like my second favorite career besides the AI intelligence. But something I also wanted to mention, so that's pretty much, I think that was the last one. Yeah, so that's it for the different careers. But what I did want to mention is what the guy mentioned in the, which one was it? In the AI video. He mentioned different majors that you could major in. So for most of the different careers or the jobs that I mentioned, you don't have to, it's not just one major, but if you want to play on the safe side, you should probably do computer science, because computer science will give you the foundation for most of these different jobs. And then after that, you can, focus on one thing or another thing. And something that I think is really cool about careers in technology is that you don't have to keep pursuing a higher degree. So they did mention if you wanted to be like a researcher, then you would probably get your master's or your PhD. But if you aren't really interested in specific research, then there honestly is no need to even get your master's or PhD. You're good with a bachelor's. There's even for a lot of those jobs as well, they don't even require one. They'll either require the bachelor's or an associate's degree. A lot of jobs will be like associate's degree or just that level of knowledge. So if you are interested in that, you can even start now. You could start researching how to code, and then maybe get a head start, see if you like it. So when you go into college, you can take a couple coding classes, see if you like that, and then you'll already have like a foundation. This summer, Google is putting on a computer science summer institute, which fits perfectly with this workshop. It will be taking place July 6th through the 31st, Monday through Friday, 3 to 5 hours per day, and it'll all be online. So I will insert a screenshot here, and I will also insert the links to where you can apply, and the deadline on the screenshot says May 5th, but the actual deadline is May 15th. So seniors, if you're interested in computer science, if you're interested in any of the technology fields, technology jobs that I just mentioned, it's a great opportunity. So don't miss out on that, and there is no GPA requirement.